Welcome to this lesson. Now in this lesson, what we are talking about is addition of vectors. So the first method we are going to be considering is how to add up vectorially. That means looking at the directions and adding the vectors up. So say for example, we know we have this is the x-axis, this is the y-axis, then z-axis. Okay, that's 3 components. Now ax is there, ay is there, and then az. So also we have bx going the same direction, then by, then bz. Alright, so if I want to add up this vector, both of, so a plus b becomes, all you just need to do is add up ax plus bx. So you just say ax plus bx plus ay plus by plus az plus bz. Okay, so that's how you add up vectorially. Now what if they are moving in different direction? Say as is going in this direction and bs is going in the opposite direction, then ay is going in the positive direction, by is going in the negative direction. Okay, so also here, say ay is going in the positive, az is moving in the positive direction, then bz is going in the negative direction. Okay, so what it just means is that it used to be, if I want to add it up, it automatically becomes a subtraction because they are not moving in the same direction. Alright, so if I want to add it up, it will not be a plus b, it will just be a minus b, okay. Now this sign you are seeing here is to show that this is a vector. There are several ways of writing vectors. Okay, we can write it like this, or we can write in notation like this, just showing that this is a vector. Excuse me, that it has a direction. Okay, so everything here becomes ax minus bx plus ay minus by plus az minus bz. Okay, so I want to look for the magnitude of this addition of the vectors. Now when we say magnitude of the vector, what we are basically saying, now each of these addition and subtraction, they all have their direction. So if I want to rewrite everything clearly here, I'll be attaching my I, because this axis is represented by I, then this axis is represented by J, and this is Z. Okay, so if I want to write this out now, this should be A minus B equals ax minus ax I plus, in bracket, ax, ay minus by is supposed to be bx, by z and g plus, in brackets, a z minus b z k. Okay, So this z is supposed to be k. Sorry. So this is showing the direction of the this is showing the components, the direction in which they are moving. The components, this is the x-axis component, y-axis component, the z-axis component. So if you want to look for the magnitude, magnitude is just like saying this is exact magnitude. Then it's just the square root of the square of each of them. We square each of them, so that will be ax minus bx all squared plus ay minus by all squared plus az minus bz all squared. Okay, this is what we call magnitude. The same thing goes for a plus b. This for a for minus b. Then a plus b will just be the opposite of it, just the sign opposite. Just ax plus bx all squared plus ay plus by all squared plus az plus bz all squared. Now this is how you add up vectorially. This is how you add up two vectors vectorially. If it was three vectors, this is how you go about it. First of all, add up two of the vectors, then when you get that your final answer, you then add up the third vector to that new vector that is formed. So that's how you add up vectorially. Now this is for adding two vectors that are not in a parallelogram, that does not form a parallelogram, that their direction does not form a parallelogram. So let's see a case where each of these forces, their direction actually forms a parallelogram. So say for example, this is at the point where the forces are acting. Then let's say the force is, one of the forces acting this way and the other one is acting directly this way. Okay, so when we complete this shape, you will see that a parallelogram is formed. Parallelogram is formed at this point. Now we know from a parallelogram, here is parallel to this side, this line is parallel to this line, that means OR is parallel to PQ. Okay, so also RQ is parallel to OP. Okay, now one thing you must know is that this force is the resultant force. Okay, this force is the resultant force. Now these are the individual force. This one that is going like this, one that is going this way, and this one that is going this way. Now we completed this parallelogram this way, knowing that this line of action is parallel to this line of action. Okay, so what I should be seeing is like this. Okay, so B, C, O, A, then B. Now if I want to get C, which is the total force acting, that is the force on this point. This point here, there are two forces acting on this point. This force that is going this way, this force that is going in this direction. So if I want to get C, which is the resultant force that is completing the diagonal of the parallelogram, all I need to do is sum up the other forces. That means from here to here to this point. So it goes like this, then to this point. So that would be line OP plus PQ. Okay, OQ So line OQ is equals line OP plus line PQ. Okay, so if we change it down to what they represent, OQ is C, OP is A, plus PQ is A, B. So for this one, this is how you get your vector. This is how you get the total vector. So if say we have two forces. Let's say this is 4 Newton and this is 3 Newton. Then all we just need to do is complete the parallelogram, and this at this point would be our resultant force. At this point, this is our resultant force. You can use any letter arrow, or in most cases in physics, what we use to represent resultant is capital letter arrow. Now, if I want to use the parallelogram method, just what is there is resultant force becomes the addition of 4 plus what? 3, and that's 7. Now this is the most simplest form of parallelogram law of force. So I will take an example. Let me clean the board. Alright, so now this equation that utilizes a parallelogram process. Now let's see how we can solve this equation. An ant crawls on a tabletop. A position vector locates the ant, okay, at a point with coordinates x equals 35 millimeter and y equals 45 millimeter relative to the origin of the coordinates of the coordinate system. Determine the magnitude and direction of this vector. Now the first thing you need to know, when they say a position vector, what they are just saying is the x-axis and the y-axis. So I think we did the position vector in one of the video on vectors where we talked about unit vectors. We actually discussed how we represent the vectors along x-axis with I and the vector along y-axis with J, and also Z with K. Okay, so if I'm to draw this diagram, I will first of all draw two coordinates, because we have a position vector that's locating the ant with x and y. So that's x and y. So now they said the position vector is that the ant has moved in a coordinate position of 35 millimeter. Okay, so I will assume to this point from here 0 to this point is here 35 millimeters. Then also y, the ant has also moved a coordinate of 45 millimeters along the y axis. Now if you extend this line and you extend this line, they will meet at somewhere. It means at this point, that's the direction, that's the point where the ant is. Okay? So they are asking us to determine the magnitude and direction of this vector. Now the first thing you do is to complete That is, take this point where the ant is now, draw a straight line to the origin. This point is the origin here. Okay, so now this line that is here and this line that I drew here, they are parallel. Now they are parallel, it means this line is perpendicular to the horizontal, that's the x-axis, and this is angle 90. So the direction, this is the resultant force. This is the resultant force. Now the angle it makes shows the direction it has moved. Okay, so these are the two things we are looking for. Firstly is the magnitude of the resultant force. Secondly is the direction, that means at what angle was the ant moving according to the x-axis. That's relative to the x-axis, because we have to relate it to something. There must be a reference plane or reference coordinate. Alright, so now we can look for something. I can say now that, sorry, this is supposed to be 45. So 45, okay, 45 millimeters. 45 millimeters. So the original diagram I'll be looking at is something like this. So here is resultant, 90 theta, 45 millimeter, 35 millimeters. Okay, I can see cosine and sine methods here. So if I want to get my resultant force, all I need to do is basically use Pythagoras theorem. Now from Pythagoras theorem, we remember that hypotenuse squared is equals the sum of the squares of the other two sides. So it could be opposite squared plus adjacent squared. So r squared, that's hypotenuse, the side facing the 90, that's hypotenuse. The side facing the angle, that's opposite. So that should be 45 squared plus 35 squared. So r squared becomes, let me get my calculator. So 45 squared is 2,225. So then 35 squared is 1,225. So 2,025 plus 1,225. That should give me 3,250. So r squared is equals 3,250. So for me to get r, I'll take the square to the other side, and that should give me r equals 3,250 equals 57.009. So I can actually approximate it to be 57. So this should be in millimeters, because we are talking about the direction. They say determine the magnitude and direction of this vector. So the magnitude that we are talking about here is not just a force, it is the direction that the ant is moving, the direction in which the ant is moving. Those are the vectors we are talking about here. Okay, so this is the magnitude of the distance it has moved from this point to this point. It has moved 57 millimeters. Now how do we get the direction? From this place we can just say this is opposite and this is adjacent. We can use any of the trig ratios, any of the trigonometry ratios. We can use sine, we can use cos, we can use tangent. So if I want to use, let's say I want to use sine, that should be sine theta equals opposite of hypotenuse. That's opposite over hypotenuse, and opposite is 45. That's the side facing the angle. Hypotenuse is what we got here now to be 57.009. I'll just go straight to the point. I'll just divide. Okay, so that should be 45 divided by 57.009. The answer I got here is 0.7893. Now, so for me to get the final answer is, I'll take this sine inverse. I'll take the sine to this side. So it becomes an inverse. So it means theta becomes sine inverse 0.7893. Okay, please bear with me for the space. Now, whenever you have sine theta equals any value, what you do is, for you to get the theta, for you to get the angle, you take the inverse of the other side. So when you go to your calculator, you just press shift sign, that gives you your inverse. All right, so I'll leave that to you. Get the answer, and to make sure you are following, just get the sine inverse for this value. Okay, so this is how you can solve using the vector directions. So we can both apply Pythagoras theorem and also the sine rules, cosine rule, and then tangent rule. Okay, so if you like this video, if this video has been helpful to you, you can like the video, right? Don't forget to share the video to your friends so that they too can also learn. Okay, that's all from my side. Thank you.